how does my wife write? Well, you say, well, she uses Braille. Well, what happens if she wants to write to a sighted person, like complete an assignment for her professor? Her professor probably can't read Braille. What she needs to do is sort of the opposite. She could give the professor the word processor file, or she could print it out if the professor prefers that. So it goes both ways. You know, we can share in a medium that is easy for sighted people, and they can share in a medium that's easy for visually impaired people. It's just the original word processor files. It's fantastic how that works. Because before, when my wife was in college and she was typing away on the typewriter, the phone rings, gets up, answers the phone, sits back down again. She often forgot where she left off because she couldn't glance down and see the page. So she had to X out a lot of stuff and then start over. That's why her papers sometimes looked like they had a lot of corrections and mistakes on them, is because it's pretty hard to type if you can't look down and see what you're typing. Thanks to talking computers, though, everything has changed. Back in 1968, my sister took me to a wonderful movie called 2001: A Space Odyssey. And do you know who the real star of that movie is? The HAL 9000 computer, supposedly invented in Illinois. Now, there was a gentleman by the name of Douglas Rain, a Canadian, who did the voice for the computer. And a lot of people thought that that is the way computers really sounded. Essentially, perfect speech. Well, that isn't exactly the way things went. I'm going to show you what I mean. Let's see how things were back in 1984. I compiled a little clip here. Katie?
It is
I'm
not
going
in backup.
to bring up the screen there, and I want you to find the file for me. I think it's called Computer Chronicles. That's it.
Okay.
This is a little video I compiled from a video on a website called archive.org.
Many people are better talkers than listeners. Also applies to computers. As we discuss in a later segment, it is much easier to program a computer to generate passable speech than it is to understand our speech. The computer knows exactly what it wants to say and can generate an unambiguous, if somewhat stilted, series of words to say it. Understanding different word boundaries, dialects, indefinite references based on global knowledge, or nonverbal signals is very difficult for anyone, computers included. An example of word boundary problems occurs when I say Sam Spade. Do I mean a fictional detective or a man named Sam who received his paycheck? Thanks to cheap, high-performance hardware and computer techniques called artificial intelligence, which we will study later, computers can now understand a limited vocabulary, or a larger vocabulary spoken by a limited number of people.
Spoken language contains variables that can completely change the meaning of a word depending on the context, the inflection, or the accent of the speaker. So for a computer to accurately analyze and reproduce speech, it needs to first break up the words into sound fragments and then reassemble them with natural speech emphasis. Synthesizing devices work either by digitally encoding entire messages or by phoneme synthesis, building words from a library of digitally stored fragments. Encoding speech into these fragments points out the primary importance of speech inflection and accentuation in determining how a phrase is pronounced.
Let's start out, Carl, if you would, please, and tell us how does the computer synthesize speech?
Well, our machine takes any ASCII text, that's the way text information is stored in a computer, and converts that to intelligible speech. It first looks at the words, decides which phonemes are in those words. Phonemes are the basic elements of speech. It puts the phonemes together for the words, it massages them to make sure that they flow the way natural speech does, and then that's converted to a set of parameters for a speech synthesizer, which then produces speech.
When you say a phoneme, tell me more about it. You say that's the basic building block of speech. What is a phoneme, literally?
A phoneme is a short sound in speech. It's the fundamental element such that if a phoneme changes, it changes the meaning of a word. Phonemes are, you can roughly think of them as being vowels or fricative sounds, and a number of other sounds. There are roughly 38 to 45 phonemes in English, depending on which linguist you speak, you're talking to. And in other languages, there are roughly the same number.
Does your product cover all of the English language?
Yes, our product takes unrestricted text and converts it to English.
When you say converts it to English, now suppose I were to type in French words.
It would attempt to pronounce them, but they probably wouldn't come out right because our phoneme models are for English, and the phonemes in French are different.
With an English accent.
So this particular device is language dependent. It's
That's correct.
programmable in one particular
That's
language
correct.
with its particular set of...
Also, the pronunciation rules, not only the phonemes, but the way the phonemes flow together are different in different languages. So in our device, we have not only models of the phonemes, but we have the pronunciation rules as well.
Carl, earlier when Herb and I were talking, we used the phrase speech synthesis, and that's different, isn't it, from speech coding? What's the difference, and what does this do?
Okay, the way to think of it is we call this synthesis by rule, because there is no pre-recorded speech or no stored speech in this device. It takes text and it produces speech according to the pronunciation rules of English. Okay, the other kind of speech, what people think of as speech synthesis, is synthesis by analysis, where the information is recorded from a human voice and then compressed or processed in some other manner by a computer so that it can be stored, and then it is simply reconstructed. There's no knowledge of what the words were, what they mean, or how they flow together. It's a sophisticated tape recording process, if you will.
Describe what you're doing.
Okay, what I've done here is with this little keyboard, I've stored some messages ahead of time by typing them in, and here's one.
Hi Stuart, hi Herb. Thanks for the opportunity to appear on Computer Chronicles.
Okay, so now you had just typed that phrase in before on the keyboard.
That's right. I can type anything on this keyboard and it will then speak it.
One last question before we have to take a break. Now, what is the product we're talking about? Is it this big blue box, or
No.
can I do something with my PC to accomplish this?
This is the product that's actually speaking. Okay, this board goes in an IBM personal computer, and this board contains the text-to-speech conversion equipment that's here. This is the microprocessor that is doing most of the controlling.
Okay, that's the way they rolled in 1984. What I want you to take away from the video is it was kind of tricky to get computers to learn how to speak, but it was easier than getting them to learn how to listen. I don't know about you, but when I encounter strangers sometimes, maybe they're understandable to their friends, but I feel like going, what? They often don't pronounce their words distinctly or properly. It's much easier to teach a computer how to talk than how to listen, because there's so many different dialects and ways of pronouncing things. There's two ways of speaking for computers. They call it synthesis by rule, and well, I like to call it synthesis by rote. If you just have a bunch of words that were spoken by a human being stored in the computer, that's synthesis by rote. If you've ever listened to some of those pre-recorded messages from the phone company, it's obvious that a lot of them were made actually with words that were patched together, spoken by a real human being. Synthesis by rote sounds great. It sounds natural, but the vocabulary is limited to the words that are stored in the machine. Synthesis by rule, however, that's the kind of synthesis that most of my devices use, takes a different approach. It actually stores the little phonetic sounds of the English or whatever language you're speaking in the computer and then pieces together each and every word with those phonetics. So if you have all the different building blocks, all the 38 to 45 phonemes, you can make it say anything. So its vocabulary is much wider. It can read just about anything you can type in, but it sounds more artificial. But the good news is that has gotten much better in the intervening 30 years. Speech synthesis nowadays sounds much clearer, much more like a human being, and the devices are much smaller. Let me give you an example of that. You remember the big computer card that they were showing? It had the synthesizer in it in 1984. Let me show you one of the tiny devices that we can use for reading now. I can store dozens and dozens of pre-recorded text files, books if you will, or documents, on this device, and I can have it read them to me thanks to synthesis by rule. Much lighter, much smaller than in 1984, and they sound much better too. But speech was such a novelty in the early days that we were willing to put up with less than optimal situations.